Bonjour. Encore une fois. Seriously, I don't speak French. After people have been coming up and talking to me in French, and I have to, I'm sorry, I speak it. I don't understand when it's spoken. I've understood the other keynote, Agnes, and by reading the subtitles, which went wrong quite a few times. Unconditional was sort of put up as a candy show, which I particularly liked. So yes, this is how JavaScript happened. And if you want to understand that as, and how can we stop it from happening again, that's fine. I'm going to talk about a lot of languages. Sometimes people get upset. They think I'm saying that a language is bad. And I'm not. All programming languages have good and bad things about them. There's a great saying, Flon's axiom. There does not now, nor will there ever, exist a programming language in which it is the least bit hard to write bad programs. Okay? Every language, you can write good programs. Every language, you can write bad programs, even Haskell. There was a time before programming languages, and we didn't have computers, and they didn't exist. And there was no sort of talk of any of this sort of stuff. But in the 19th century, in the early 19th century, in Britain, a chap named Charles Babbage went to Parliament and said, give me £500,000, which was really a lot of money in those days, and I will build you a machine that can think. And so they gave him the money, and he started to build it. And he got about halfway through, and then he had a better idea. Does that sound familiar? And he went back to Parliament and went, give me £1 million and I'll build you a machine that can really think. And he started building it. And so they were the calculating engine and then the difference engine. And the difference engine, he presented at a salon in London, a kind of share what you're working on, kind of like a tech conference, really. And one of the people at that salon was this young lady. This is Ada Lovelace. And Ada Lovelace was the daughter of the romantic poet and one-man syphilis epidemic, Lord Byron. And her mother decided that the best thing she could do for her daughter was to keep her as far away as possible from her dad. And so she was privately educated, she had tutors, she learned mathematics, she was insanely clever and very accomplished. And she went to this salon and she met Babbage and he explained her engine. He explained his engine to her. And an Italian, whose name I've forgotten, had written a book about Babbage and his creations. And Ada translated that book into English and also added her own annotations. And one of the annotations she added was a program for calculating Bernoulli numbers, whatever those are. And so to do this, she had to invent a notation to describe the language because she couldn't do it on the machine because the machine only existed in small prototypes. And so this is really the first programming language. And then from 1850 to 1940, nothing happened. Literally nothing at all. The world just, we slept. It was like Sleeping Beauty. And then in 1940, we decided that was boring and what we should do to entertain ourselves was have a war. And the thing with war is you've got lots of soldiers in lots of different places and they're communicating, and they were communicating over the radio. But you don't want the enemy to be able to understand your messages. And so we had different machines for doing encryption. And the Nazis had this. This is the Enigma machine. And the Enigma machine, you had different dials that you could put in different orders. And then at the front, you had these patch panels where you connected different cables together. And it was hundreds of millions of possible combinations. It was impossible to guess. Some Polish soldiers captured an Enigma machine from a German U-boat, and they gave it to the British intelligence service, along with some early research and work they'd done on building a bomb. And this is a machine that can basically just rattle through possible combinations of the Enigma dials and patch cables. And when it comes to one where it's actually putting out proper German, it can go, I found it. And that was great, and that worked. And we didn't tell anyone that we could do this. And the Germans never knew, the Nazis never knew that we were intercepting and decoding their transmissions. But despite that, the seriously ultra top secret messages were encoded using this machine in the later part of the war. This is a Lorenz cipher machine. And this has more possible combinations than there are atoms in the solar system. It's a lot, right? And so to crack the Lorenz cipher, we needed more powerful machines. And so Alan Turing and a chap named Tommy Flowers, whose day job was working for the post office, built Colossus. And this was the first programmable computer. And so this we built, and we could use this to crack the Lorenz cipher. And then we won the war, thank all of us. French, the British, the Allies, we won the war, and the British government smashed the Colossus machine into tiny pieces and classified it as ultra top secret, and so we weren't able to tell anybody about it until the 1990s, which means the world thinks the first programmable computer was the ENIAC. And it deflated a few American egos once we were allowed to go, actually, we built one before you, like 5-10 years before you. So these are the ENIAC programmers, and you may notice something about them. They're all wearing skirts. All the ENIAC programmers were ladies, and not only were they the ENIAC programmers, the men who had built the ENIAC, because that was proper manly work, didn't bother documenting anything. And so these ladies had to figure out how the damn thing worked and then program it. And there was no programming language, it was patch cables. You would connect this to that and this to that and this to that, and then that was your program, and then you would turn it on and it would run and it would produce output, and then you would turn it off again. And that was how we programmed computers for a very long time. And then IBM built proper, like what we now know as computers, digital computers, like this one, the IBM 701. And this was programmed in machine code, literally the hexadecimal numbers for opcodes and values, and that was how you programmed in those days, in the 1950s. And so this is the formula for calculating trajectory. One of the main uses for computers in those days was, if I fire this munition with this much gunpowder at this angle, who will it hit? And it was important to be able to figure this out. Now, that's quite a simple formula in mathematical terms, but somebody had to take that formula, properly understand how things like sine and cosine and tangent worked, and translate it into this, which is just insane. And nobody really liked writing this kind of code. And then this chap came along. This is John Backus, and John Backus was walking down the street in Manhattan one day, and IBM had a building in Manhattan, and through the windows of the ground floor, you could see the IBM 704, which was their next computer, with lots of flashing lights on it. One of the interesting things I learned researching this talk is that those flashing lights were mostly marketing and not actually informative at all. He saw them, and it worked on him, and he went inside and went, I want to work with that thing, can I have a job? And they went, yeah. And the thing with John Backus, the thing that you have to understand about John Backus, is he was lazy. He was a very lazy person, and he did not like programming in machine code. And Bill Gates actually says, if I have a difficult job, I choose a lazy person to do it, because they'll find the easiest way. And John Backus wanted an easier way to calculate, to translate formulas into machine code. And so we went to IBM and said, I've got this idea where you type in the formula and then the machine does the transformation, the translation into machine code, and then you run that, and then you get your answer out. And IBM, very weirdly for them, said yes, and they gave him a team of people. And this team of people bounced around various offices in Manhattan for 3 or 4 years, coming up with the first programming language ever. And it was a programming language that translated formulas. It was a formula translator. And so they called it Fortran. And it was released in 1957. And it looked something like this. This is FizzBuzz, written in Fortran. And you can see we have loops, and we have do 40, which means do this down to line 40 and then come back up here again. So that's like a for next loop, but that was how they did that. And then we have line numbers for any line that we might want to go to. And so we say if it doesn't divide by 15, then go to 20. Otherwise, print asterisk and then continue, which goes back up to the do, and so on, going down like this. And there were a few things that Fortran had that we still have to this day. And the main one that leapt out at me was the I. Why is it for I equals? So there's 2 reasons. One is that lowercase I has always been used in maths as the indexer on numbers. So you have like AI plus 1 and so forth. Because Fortran was created by mathematicians, they decided that any variable that started with I, J, K, L, M, or N was an integer, and all the other names were real. And so if you needed an integer, which you need for for loops, then you needed a variable that started with I. Let's just stop there. And we'll just use I. And so even today, if you see loops that are just going through like a 2-dimensional array, it's for I, for J, for K, we nest them like that. And that dates back to Fortran, where if it started with I, it was an integer. They later introduced actual declarative typing into Fortran, which led to the hilarious joke, God is real unless declared integer. The other thing we got from Fortran, so you can see here, we have how to do multiplication. So this is just factorial in Fortran. And oh look, there's a times sign there. So times is not X, it is its own character, except that character wasn't available on the typing machines that you used to create the punch cards to write Fortran. And so they went for the character that looked the most like it, and they used the asterisk. And every language since then has used the asterisk, and fair play to them. This is a Fortran statement, a line of Fortran code written on a punch card, and this punch card has 80 columns. And to this day, if you install Visual Studio or IntelliJ IDEA, the line width still defaults to 80, and then it will try and wrap. And that 80 character limit comes from punch cards. Not from Fortran particularly, but from punch cards. So, Fortran gave us the if statement, it gave us the asterisk for multiplication, and it gave us I as the iterator variable. And then this chap came along. This is Edgar Dijkstra, however that's pronounced, I can never say it. And he didn't like Fortran, and there was one thing in particular he didn't like about Fortran, and it's probably the most famous quotation in the whole of programming. Goto considered harmful. To this day, you're not allowed to use Goto, even in places where it would save you like lines and lines of code or tortured ways of avoiding it. But he said Goto, he wanted structured programming. He wanted functions and sensible ways of redirecting control flow and all that sort of stuff. If you go and look for Edgar Dijkstra quotes, there are some fantastic ones. My favorite is this one. If debugging is the process of removing bugs, then programming must be the process of putting them in. Guilty. So this desire for a more structured programming language led to ALGOL. And ALGOL was the first programming language that was created by a committee. It was a bunch of people sitting around a table and saying, I think it should do this, I think it should do this. None of the people sitting around the table had any intention of implementing ALGOL. They were just defining it. Implementing it was somebody else's problem. The first version of ALGOL came out in 1958. It was called ALGOL 58. And you can't actually do FizzBuzz in ALGOL 58 because it didn't have I/O. They added that in ALGOL 60, the ability to print stuff. So ALGOL 60 FizzBuzz looks like this. So you can see we've actually got kind of begin and end and for, and it's more structured, and it introduced the idea of functions. So you can see there we've got outstring. That's a function that's built into ALGOL's standard library that writes something to the standard output, and out integer if you just want to print the number, and so forth there. And so yes, we get if then, we get the for loop came from there, but it's still a slightly weird syntax. There's the colon equals for assignment, which some languages, I've just been writing some Go for my day job, and it still uses colon equals for assignment and initialization. And one of the other interesting things that happened with ALGOL, so when you're sitting around a table in a committee defining a language but not implementing it, you need a way to describe the language, a sort of proper technical way of describing the language. One of the people on the ALGOL committee was John Backus, and he was the only one, obviously, who had any experience of actually designing and implementing a programming language. And he had come up while he was working on Fortran with a way of describing Fortran's grammar. And he extended it as they were developing ALGOL, and it was he called it Backus normal form. And this is ALGOL, the for statement, described in Backus normal form. It was actually changed, so one of the other people on the committee was Peter Noor, and he worked with John Backus to refine BNF, and so then somebody went, oh, we should call it Backus-Noor form, and it is called that to this day, and it is still the primary way we technically describe programming languages. This is the BNF for JavaScript's loops. And so, yeah, we got a lot of things from ALGOL. We got block structure, if, then, else. It also had switch. It was the first language to use for as the word for loops, functions, semicolons at the end of lines. I forgot to mention that, but yep, we have the semicolons at the end of statement lines. And Backus-Noor form, which we are still using to this day. ALGOL also was the basis for a lot of research languages, people kind of going, oh, I've got this idea for a new programming paradigm. Let's add it to ALGOL because it's nice and easy. One of those, which I mentioned in the keynote earlier, was ALGOL W, which introduced null. So thanks for that. It was unavoidable. This is ALGOL W. If you have records and then you have pointers to records, you have to deal with the fact that you might have a pointer to a record that there isn't one. And so you have to have null. But yes. At the same time as ALGOL, over at MIT, this chap, John McCarthy, was working in the MIT AI lab. And they thought they were about 5 years away from artificial general intelligence. How far away are we now? It's about 5 years, isn't it? They were trying to model the way the human brain works, and the best that they could come up with was we've got lists of things, and we look when we see something new, we go and we find the lists that that thing is in, and then we use that to understand the world. And so what he wanted was a language that was very, very good at processing lists. A list processing language, Lisp. Not to be confused with Lisp, which is a language for processing lists. I'm sorry. This is FizzBuzz in Lisp. So you can see we define a function called FizzBuzz, and then we have a loop for n from 1 and below 101. And then we define a divisible by 3 function and a divisible by 5 function, and then we use cond, which is kind of Lisp's version of switch, and we can then say if it's divisible by 3 and divisible by 5, then write FizzBuzz. So the main thing that we've got here is higher order functions, first class functions. You can pass functions as parameters to other functions, that you can throw them around the place. Everything in Lisp, including the source code, is a Lisp list. And that made it very, very easy to build complex systems. Although, yeah. You can always spot a Lisp programmer at a conference, because one hand's typing, and on the other hand, they've got this, kind of how many parentheses deep am I? Using that thing with the knuckles where you can count to 12 on your fingers. The other thing I thought was really interesting about Lisp, has anyone done Lisp programming? You know car and CUDA? So car is the first item in the list, and CUDA is the rest of the list. I may have that the wrong way around. But yeah, do you know where that comes from? Yeah, I didn't. So, the IBM 704, which was the machine that John McCarthy had access to that he implemented Lisp on. These days we have 8-bit, we have 16-bit, we have 32-bit. There was no concept of bytes or anything like that back in those sort of Wild West frontier days. And so the IBM 704 had 36-bit registers. And you had a prefix, and then you had the decrement part, and then you had some bits for the tag, and then you had the address part. And so for Lisp, which was the first language that was using a heap, he needed pointers to the first item in the list, and then a pointer to the next item in the list, which would also have, and so on and so on. That's the way linked lists work. And so CUDA stands for content of decrement register, and CAR stands for content of address register, which is just a fantastic example of the implementation bleeding into the actual terminology of the language, because we still call it that, even though address registers and decrement registers haven't existed for 50 years. But yeah, so Lisp gave us first-class functions. It was the first programming language which used a heap. And if you have a heap, you need a garbage collector. And so Lisp had a garbage collector. It also had something that was sort of like a JIT compiler, but not really. So I'll come back to that later. Okay. In Norway, in 1962, a couple of guys working at the Norway Institute of Technology, or whatever that's called, came up with Simula, which was based on Algol, but introduced the idea of objects and object-oriented programming. A lot of people think Smalltalk was the first object-oriented programming language. It wasn't. It was Simula, 10 years before Smalltalk. And so you can see here we have a class printer which has a method, a procedure, print, and then we can, down at the bottom here, we can create an instance of that printer. And this is great because we can actually pass in, if it's divisible by this, print this. If it's divisible by this, print this. And so we could make FizzBuzzes that worked with other numbers. Ah, the flexibility of object-oriented programming. So yes, again, this was a research language. Nobody really built anything particularly complicated with it, but they did introduce most of the ideas that we still have in object-oriented programming today. So classes, inheritance, polymorphism, and also the idea of scope or visibility. So you could declare fields as private and protected, although I think they used the word hidden in Simula. I love this one. APL. Anyone ever done APL programming? Sort of a bit. Okay. So APL was created in 1967 as a teaching language. So this guy, Kenneth Iverson, taught programming at an American university, and he wanted a programming language that was easy and simple to grasp and simple to teach his students to write programs with. And he thought a notation must allow convenient expression not only of notions arising directly from a problem, but also of those arising in subsequent analysis, generalization, and specialization. And so he created APL, which does actually stand for A Programming Language. Not the most creative of people, you might think. Wait till you see FizzBuzz in APL. That's it, that's the whole thing. Okay? It's terse. Conway's Game of Life in APL is also a single line of, and it looks roughly the same length as that. Conway's Game of Life doesn't have the strings, so it's got a little bit more in there. But you may notice that. What's that? And these things, okay. So yeah, rather than using keywords, Kenneth Iverson decided he was going to use the Greek alphabet. And my theory, and to this day no one has disproved this, is that he gave APL away for free and then charged $1,000 for the keyboard. So, you know. But APL, things that are derived from APL are still used today. The main thing with APL that made it like amazing is you could say, do this operation for every element in this array, and it would do it as fast as it could. So these days, if you're writing code and you've got 128 cores, the APL compiler will use all of them to do that calculation. That didn't make it into JavaScript. And I can't work out whether that's a good thing or a bad thing, giving that kind of power to front-end developers. I love you guys. You do something I cannot do. I'm purely back-end. But the other thing that APL had was dynamic typing. So the type in APL was an array, and into any element of an array, you could put any type. And so that dynamic typing came from APL. Also in the 60s, we had BCPL, which stands for Batch Control Process Language, and CPL, which is Control Process Language. And these were used quite extensively in Multics, which was an operating system that didn't really succeed. Project at Bell Laboratories that never made it into production. But Multics was a multi-user operating system. This is FizzBuzz in B or BCPL. And this was the language that introduced the idea of a curly brace instead of begin, and a closing curly brace instead of end. And that was great, except at the time, a lot of computers were still using IBM's EBCDIC encoding for text, which sometimes had curly braces, sometimes didn't, and the various implementations that did have them put them in different places. And so you couldn't use curly braces if you were using the EBCDIC character set, so you could, if you needed to, use $open paren and $close paren. Hello, PHP. But yes, so BCPL gave us curly braces, and then somebody went, oh yeah, this is great. And some of the guys who'd been working on Multics, Dennis Ritchie and Ken Thompson and Brian Kernighan, they made a joke operating system. It was like a mockery of Multics. And they thought, no one's ever going to use it. But because it was a parody of Multics, they called it Unix. And they needed a programming language to write Unix in, the Unix kernel and all the various commands and so forth. And so they came up with C. And then Brian and Dennis wrote a book on how to program in C called the C Programming Language. I learned programming from that book. Anyone else? It's really good. Honestly, I've got both my kids. I'm going to try and get them to learn C from that book. It teaches you low-level stuff without being as horrible as assembler. This book, of course, was the first time that the first program you wrote was Hello World. Nice, friendly, easy, and tricked you into learning the rest of C, at which point you were screwed. So this is FizzBuzz in C, and it's lovely. And there's a reason why C is still used for a lot of stuff today. Although at least one of those reasons is just Linus Torvalds. This, however, is also FizzBuzz in C. I can't see that the word fizz is not in there, the word buzz is not in there, but you put this into a C file and compile it with GCC, it will print the numbers from 1 to 100 with FizzBuzz in there. This is an entry into the International Obfuscated C contest, which happens every year, and is basically who can write the most horrible, ununderstandable code. They had to change the rules because one year a guy submitted an empty C file, which if you compiled it with a very specific compiler with a specific set of flags, would actually produce an executable. And they went, right, they added a rule saying the program must be at least 1 character. But you can do obfuscated programming in JavaScript as well. That's Hello World in JavaScript. My friend Dylan Beattie has an excellent talk which explains why that is Hello World in JavaScript. And every time he does it, there's about 2 minutes where I understand and then it goes. So I can't explain how that works. But so C gave us what we now call the C style, curly braces, semicolons, all that sort of thing, gave us Hello World. It gave us the idea of truthiness. So before C, you had to have a Boolean operation. C was the first thing that says any number that's not 0 will see as true, which is why you can do while C equals getchar in a loop, and it just evaluates that expression and then says, yeah, that's truthy. And obfuscating code for fun and profit. Seriously, I was helping somebody with their C++ homework once, and it was validating ISBN numbers, book numbers. And I helped her write the actual code to hand in. And then I went, can I turn this into a for loop with no body? And I could. And I said, hey, show your teacher this as well. And she came back and went, my teacher says I'm not allowed to talk to you anymore. Okay. Also in 1972, Smalltalk came along. And Smalltalk was born out of a need for an object-oriented programming language. It was created at the Palo Alto Research Center, Xerox PARC in California. And it was built because they were building a new kind of computer with a new kind of interface, a graphical user interface, windows, icons, menus, and pointers. Now, when you're writing code for a terminal, there's a limited number of things that the user can do, and generally you take them through a process, you ask them questions, they answer the questions, and you have control over the flow of the program. So imperative programming works really well for that. When the user can just click on anything that they want on the screen, you need some way of reacting to clicks. And so they created Smalltalk with this idea that when you clicked something, it would send a message to an object which could then handle that message. And this is still the way that Windows and Mac OS and Linux desktop stuff work to this day. And so this is FizzBuzz in Smalltalk. And because we can monkey patch things in Smalltalk, we say, let's add a method FizzBuzz to integer. And if we receive the message FizzBuzz, which takes this parameter here, we're going to say, self is kind of like this and so forth. But so Smalltalk created the idea of monkey patching, which you can do in JavaScript. The spiritual continuation of Smalltalk is, of course, Ruby. And if you've ever had to work on a large Ruby code base, then you'll understand why monkey patching is a really bad idea. But Smalltalk also introduced the idea of everything is an object. Objects are objects, classes are objects. They're instances of a meta class called class, and guess what that meta class is? It's an object. which JavaScript has really kind of taken and run away with. So Smalltalk gave us reflection. Smalltalk was the first language where at runtime you could go, hey, what kind of object are you? It gave us the console. They needed somewhere to write debug messages to, and so Smalltalk had console.log. It had a virtual machine, which of course most modern languages have some kind of virtual machine. Java, .NET, JavaScript has a VM. Lua these days has a VM. And it had a proper JIT, so it did actually compile to bytecode, and then the runtime would take that bytecode and compile it into machine code, and then keep that machine code until the program exited. I want to come back to that in just a moment. Everything being an object also came from Smalltalk. It wasn't actually the first JIT compiler. Does anyone know where the first JIT compiler was actually implemented? 1968. Okay, I'll give you a clue. This is FizzBuzz in the language that had the first JIT compiler. It's regular expressions. Regular expressions were created in the 1960s. The guy who wrote the first implementation of regular expressions, they ran too slowly, and so he made a JIT that translated the regular expression into machine code. If you've ever used .NET's regular expressions and it's got a regex options .compiled, that dates right back to the 1968 implementation. That code sample, I didn't write that. I'm not that sick. I found it on GitHub in this gist, and this is the README for it. He just thought it would be funny. So thank you, dude, who thought that would be funny. You were right. 1973, so Lisp was kind of early functional programming. In 1973, they started to formalize functional programming as a concept. So this is ML, and looks a lot like F#, because F# is essentially just ML with .NET. Most functional languages are some sort of variation. They owe a debt to ML. JavaScript, there's not a lot that was introduced in ML that wasn't in Lisp that JavaScript has used, but the arrow function, that equals greater than as the lambda syntax, which JavaScript now supports, that came from ML. Then we got Scheme, and Scheme 1975 was created by 3 professors at MIT for teaching the Computer Science 601 introductory course. And it was a simplified version of Lisp. It was easier to reason about. And by the end of that 601 course that year, you would be able to write Scheme in Scheme, which was kind of weird. This is FizzBuzz in Scheme. Basically looks an awful lot like Lisp. The main thing that JavaScript takes from Scheme is that it was Scheme originally. So when Brendan Eich was given a few days to prototype a language for a tech demo for Netscape Navigator 2.0. He went, right, I need to write a programming language fast. I remember Scheme. I'll write Scheme. And then they came back and he went, yeah, there you go, it's Scheme. And they said, no. Our competition is Java. Make it look like Java. And so he had to change it all so it was curly braces and semicolons and all that sort of thing. But actually underneath, what he was doing was translating that to Scheme and then running it. Nice and easy. So then, kind of ignoring Smalltalk, going from Simula and from C, Bjorn Stroustrup created C++, which is a hilarious joke because it's C+1. And yeah, he's basically said this about it. C++ makes it harder to shoot yourself in the foot, but when you do, it blows your whole leg off. Who's been there? This is FizzBuzz in C++. JavaScript didn't really take very much from C++, and I'm kind of glad because this is... When I learned C and I'd written like big systems in C, and then they went, oh, no, you have to do C++. And you're kind of like, what is this? C out less than. This was how you did print. And it's why not just print? I don't understand. So yes, fortunately JavaScript didn't take that. But the thing that C++ did give us, which isn't shown in the FizzBuzz code, is exceptions. Try catch, the idea of throwing an error, attaching the current program state, like a stack trace and any sort of helpful variables to it, and then having that bubble up so you could handle it at a higher level in the program. So yeah, throw, try, catch. The whole concept of exceptions was introduced in C++. Someone will probably come and say, oh no, it's actually in something else, in which case I will update the talk, and next time it'll be right. I used D2 to create these slides, and it went mental when I added self. I kind of went mental when I discovered self because I'd never heard of it. I've been doing this for 30 years. I've used dozens of languages. I'd literally never even heard of a programming language called self, but you know, there it is. Self was a graphical programming language. There was no way of writing it in text. This is what it actually looked like when you were working with it. But self introduced the idea of prototypal object-oriented programming, prototypes. And the cool thing about those is that you can implement them in Scheme. And so when Brendan was creating his scheme for Netscape Navigator and he wanted object-oriented programming, he stole prototypes from self. Stole, you know, I'm not saying that in a bad way, we're all stealing. So yes, prototype-based OOP. Love it, hate it, it came from self. And then, of course, there was Java. James Gosling sitting in his room at Sun Microsystems, looking out the window, seeing an oak tree, creating a programming language called Oak, being told no. That's not a good name for a programming language. But yes, he created Java, which kind of took C++, added garbage collection and memory safety and a virtual machine so it could run anywhere, which Sun really needed because nobody else was writing compilers that targeted Sun SPARC processors. So it was very helpful for them. You could write code in Java, run it on proper CPUs and Sun's weird ones. And yeah, Java became enormously popular. This is FizzBuzz in Java. Takes guts to say that at this conference, honestly. No, yeah, you can write FizzBuzz in Java. It looks exactly like the C FizzBuzz, to be honest, but it's just fun talking about factories and managers and factory managers and manager factory managers and enterprise beans. But yeah, seriously, .NET is no better. And then we got JavaScript, and it's taken ideas from so many other things, and I think that's fascinating. I just think it's really interesting to have an understanding of where these things came from, who thought of them, why do we use I as our iterator variable, that sort of thing. I had so much fun. I've done more research for this talk than I think all the other talks I've ever done put together. I'm seriously thinking about writing a book because 45 minutes doesn't do it justice. There's been some great personalities in there. There's just a lot of interesting stuff. Of course, a programming language isn't released and then that's it. JavaScript has evolved over the years. And you know, when it launched, it didn't have the arrow syntax for lambdas, didn't have lambdas. That was added later, but taken from ML. And so there are languages that were released after JavaScript, which have introduced concepts, and then JavaScript has gone, ooh, or ECMA, I suppose, have gone, ooh, that's a good idea. We'll have that. So one of these languages you may have heard of is C#, which also was inspired by C++. Definitely C++, not Java. No. It wasn't Microsoft just saying, can we make a Java compiler, being told no and going, right, well then, we'll go off and do our own version of Java. C#, of course, is called C# because it's C++++, and then you put two of the pluses under the other two pluses and it makes a hash. Makes a sharp symbol. But C# has introduced some great ideas, one of them being async and await, or if you want the negative aspect of that, colored functions. But yes, so, and you now have async and await with promises in JavaScript, and I am interested and excited to see where programming languages are going to take us over the next 10 years. If anyone does anything interesting, I'll see if they'll let me come back and talk about that. But for now, c'est tout, s'en aller. Merci beaucoup. Au revoir. I never finish on time. That was insane. Thank you.